Hello and welcome to Chapter 11, Section 6. Today we're going to talk about radical expressions. Radical is another name for the square root sign. So we're actually just talking about square roots. There are a lot of different types of radical expressions, anything that's got a square root sign in it. Their new vocabulary word today is a radicand, which I have never ever heard anyone ever use. It is the expression underneath the square root sign. A radical expression is in its simplest form when there are no perfect squares in the radicand and there are no fractions in the radicand and there are no square root signs in any denominator. And you know, if it's telling you about its simplest form, that's what it's going to ask you to do. We get to simplify radical expressions. So let's try some of these together. Here is a fraction underneath the radical sign. Now, if you've got a fraction like this, this is the square root of 2 over the square root of 72. These are the same things. Now the square root of 2 is the simplest as it can be, but this isn't simple. I can't have a radical under this sign. So I've got to find a way to reduce this. Well, I'm going to break it up into its parts. This is actually 9 times 8. And the square root of 9 is 3, so I can pull that out. And the 8 is actually 4 times 2. I can pull that 4 out. The square root of 4 is 2. So I've got the square root of 2 over 6 times the square root of 2. And if I divide the top and the bottom by the square root of 2, those cancel out, and I end up with 1 over 6. That was a heck of a complicated one to start out with. Let's see what else we've got. Here I have the square root of 3 squared plus 4 squared. So I'm going to actually have to figure that out. This is the square root of 9 plus 16. And 9 plus 16 is 25. And the square root of 25 is 5. Now you're going to notice in this section that they don't say plus or minus 5. They give some ridiculous reason why it no longer applies, and you don't get in trouble for saying plus or minus anymore, or not saying it. So we're just going to go with the positive answers, unless otherwise noted. Here we have the square root of x squared plus 8x plus 16. Now, it would be fantastic if this was a perfect square. Let's check. Is this the same as b over 2 squared? 8 divided by 2 is 4, and 4 squared is 16. So this is actually x plus 4 squared, square root of. And so the square root of something squared is that. So the answer is x plus 4. This is one of the big deals in algebra. This is one of those things where I'm just going to ask you to step your way through it. So pause here and check it out, number 1. This is a really important section for you to get, so please pause here, give it a shot. Square root of 256 is 16, square root of 4 is 2, so our answer is 8. 40 plus 9 is 49, our answer is 7. 25 plus 144 is 169. Our answer is 13. And anything squared, square root, is going to be 3 minus x. And they do give you an answer that says if you don't know if x is positive or negative, you have to put an absolute value around it. I'm not going to mark you wrong for that. But that might bite you in Algebra 2 or trigonometry or something like that. So. Now we're going to go through the property of square roots. For any non-negative real numbers a and b, the square root of a times b is the same as the square root of a times the square root of b. And fractions work that way too. The square root of a over b is the same as the square root of a over the square root of b. So this is a property of radicals. And then they want to show you that the square root of 100 is 10, and the square root of 4 times 25, which is 100, is the same as the square root of 4 times the square root of 25, which is 2 times 5, which is 10. So you can work it out either way. So we've got a few problems here to simplify together. The square root of 18 is the same as the square root of 2 times 9, and the square root of 9 is 3. So our answer here is 3 root 2. Anytime you've got a variable with an even number, you know that you can take the square root of it. Square root of, this is essentially x squared times x squared. Square root of x squared times x squared is x times x, which is x squared. You can take one of them away. When you've got an odd numbered power, you can take y squared out of there, but you can't take that third y out. So the square root of x to the 4 is x to the 2. And y squared can come out as a y, but there's still a y left under the radical. We can also spell it out if you'd like. The square root of x times x times x times x times y times y times y. If we want to do it pictorially, x times x is x squared. So the square root of that is going to be x. X times x, square root is x. Y times y, square root is y. And I have a y left. And out here I have x squared y, root y. Okay? Here we have the square root of 5 over the square root of 9, and the square root of 9 is 3, so our answer is root 5 over 3. And I don't have a square root in my denominator, so this is simplified. Here I've got the square root of a to the 5th. Now I can take a square root of a to the 4 out. So I've got, if I take 4 of the a's out, the square root of that is a squared. And I've got an a left. The bottom is square root of 81a. Well, 81 is 9 times 9. So I can take out a 9, but I've got that root a left. So I am left with a squared root a over 9 root a. And again, I've got the same thing on the top and the bottom of a fraction. They cancel out, and I end up with a squared over 9. This is a whole system of simplifying square roots. And I'd like you to get comfortable with it. So give checkpoints 2 and 3 a try. 2 is going to be multiplied together, and 3 is going to be divided, the fractions. Pause here, give them a try. This is important. Please give it a try. Come back when you're done. So for 2a, 128 is the same as 2 times 64. Square root of 64 is 8, and I'm left with that 2. I can take 2 x's out, and 1 x is left. I can take 2 y's out. 48 is 4 times 3. Because it's 4 times 12. And so I want to take out this square root is a 2 and this square root is a 2. So 2 of them makes a 4. I can take that a squared out, but I have to leave that b. So it's 4a root 3b. For 3a, I've got the square root of 12 over the square root of 27, which gives me the square root of 4 times 3. Over the square root of 9 times 3. Square root of 4 is 2 root 3. Square root of 9 is 3 root 3. and top and bottom cancel each other out, and my answer is 2/3. Square root of 36, which is 6, over the square root of x to the 4th is x squared. Square root of y to the 6th is y to the 3rd, and the square root of 4 is 2. They can get a little more complicated. So let's try them with some bigger numbers. Square root of 80 is the square root of 4 times 20. And 20 is 4 times 5. So there's 2 square roots I can take out. And the square root of 25 is 5. So I'm happy with that. I'm going to take out this 4, which gives me a 2, and this 4, which gives me a 2. So I've got 2 times 2 is 4 times root 5. 4 root 5 over 5. And that's my answer. This one, 4 is a square root. Well, let's separate them here. Square root of 4x5 over square root of 9. This is 3. We're easy with that. This is 2. And I can take 4 x's out, which gives me 2 x's on the outside, but there's 1 x left over. So that is my answer. Try to check it out, number 4. Pause here and come back when you're done. We're almost there. For 4a, we have root 20 over root 49. Square root of 49 is 7, so we're done. 20 is 4 times 5. I'm going to take out that square and leave the 5 underneath. Z to the 5th, I'm going to take 4 of those z's out. So now I have z squared on the outside with 1 z left on the inside. 25 square root is 5, and y squared square root is y. Square root of p to the 6th is p to the 3rd. Square root of q to the 10 is q to the 5. And that's it. We're done. Okay. This is a big deal, so we're going to focus on it. Your homework tonight starts on page 833. You're going to do numbers 24 to 60 every 3rd problem. Please let me know if you have any questions, and I will see you tomorrow. Take care.